Good morning to one and all. In the last video, we discussed about the basic signals that are used in the analysis of the signals, and we also seen that those basic signals are used as the construction of the complex signals. Now we are going to discuss about some more basic signals that are used in the construction of the signals and analysis of the systems, and to solve the complex problems in the analysis of the signals. So let us start this session. Other useful basic signals, sometimes we treat them as a functions also. First one, signum function or SGN of t. It is also called sine t function. So it is defined as SGN of t or signum function. SGN of t equal to 1 for t greater than 0, SGN of t equal to -1 for t less than 0. If t is positive, it is +1. If t is negative, it is -. So it is called sine function. The graphical representation of this function is shown below. So for positive values of t, it is +1. For negative values of t, it is -1. This is SGN of t function, which is a using basic function that is used in the analysis of the sine of the signal. And in terms of step function, it is defined as SGN of t equal to 2u of t minus 1. So you can solve this by using simple mathematics once you know the operations on the amplitudes. So that will be discussed in the next conversations. Next signal is exponential function, basic function that is very much used in a practical scenario. This is exponential. Based on the exponential function, some of the formulas, some of the problems are solved. So the exponential function notation is x of t equal to e power minus alpha. It is real exponential actually. If e power j omega t, it is complex exponential. So it is exponential function e power minus alpha t. Based on the value of alpha, there are different types of signal, exponential signals are defined. So the shape of exponential can be defined by using based on this alpha or a, the constant which is multiplied in the power of e. There are some shapes that can be based on the values of a. First one. So if a equal to 0, x of t equal to e power 0, that is equal to 1. So it is a DC signal. X of t is a DC signal. If a is less than 0, that is, if it is negative, x of t equal to e power minus alpha t. Now the signal is known as decaying exponential. If a is greater than 0, a is positive, then it is x of e power alpha t. So the signal is rising exponential. This is decaying exponential e power minus alpha t, and this is rising exponential e power plus alpha t. So based on the value of alpha, it is either decaying or rising exponential. Rectangular function, rectangular signal or rectangular function. So rectangular function general notation is this one: x of t equal to a rect of r by t, where capital T is width of this rectangle. If it is symmetric one, it is minus t by 2 to plus t. But the width of this rectangle base value is t. R is the center, so where it is here located. Okay. So r by 6, x is equal to rect of r by 6 minus 3 to plus 3. This will be the example. For amplitude is 4 and having width of minus 3 to plus 3. This is the notation t by t, whatever it is, t by t or r by t. This is the rectangular notation. Similarly, the triangular function, triangular x of t equal to a of 1 minus mod t by t, here t, mod t by t. So this is minus t to plus t, width of the pulse indicates this one, minus mod t to minus 2 to plus 2, that is 1 by 2 we have. X of t equal to a into 1 minus mod t by t, where a is amplitude of the signal. For example, x of t equal to a into 1 minus mod t by t. If any function is given like this, you can directly say that it is a a triangle function having its weight from -5 to plus, that is the base function is 10. 1 mod t plus t minus t. So plus t minus t, okay, plus t means positive slope, minus t means negative slope, so they are added. It is the triangle. It is nothing but sum of two ramp function. One is growing ramp function and one is negative ramp function. Both are combined, you will get triangle function. So this is the definition of a triangle function. And the sinusoidal function. The sinusoidal function will be of the form x of t equal to a sin omega naught t plus or minus 5. So if a equal to 0, then x of t equal to 1. So it is a pure DC signal having constant amplitude. Okay. Next, if alpha is less than 0, that is alpha is negative, then x of t equal to e power minus alpha t. It is known as decaying exponential. If a is greater than 0, that is alpha is greater than, that is alpha is positive, then x of t equal to e power plus alpha t. It is growing or rising exponential. The graphical representation of decaying exponential, that is e power minus alpha t, is shown in this figure, and the growing exponential, that is x of t equal to e power plus alpha t, is shown in this figure. Next one is rectangular pulse. So rectangular pulse is next rectangular signal. So rectangular signal is limited by this function x of t equal to a rectangle t by capital T, where capital T is the complete width of this rectangle. So this is the notation, this is symmetric about its vertical axis. So for example, if for rectangular of t by 6, 4 is its amplitude and minus 3 to plus 3, the spread, the rectangular pulse is spread over minus 3 to plus 3 with constant amplitude of plus 4. So this is a rectangular function. So you can write this rectangular function in terms of u of t functions like this. U of t minus t by 2, t plus t by 2 minus of u of t minus t by 2 will give this rectangular function. That will be discussed after in the problem discussion. So next, triangular signal. Triangular signal is denoted by x of t or tri of t, and this triangle function will be like this, defined like x of t equal to a 1 minus mod t by capital T, and an example is shown here, a into mod 1 minus mod t by 5. So here the spread is goes from minus 5 to plus 5. This is a rectangular function. So rectangular function, triangular function nothing but adding of a positive slope and negative slope. Positive slope during the negative time cycle plus negative slope during the positive time cycle will give the triangular function. This is another basic function that is used in the analysis of systems signals. And next one is sinusoidal function. The sinusoidal function is the form x of t equal to a sin omega naught t plus or minus 5. Here a is the amplitude of this sine function, omega naught is angular frequency, and omega naught equal to 2 pi f naught. F naught is the fundamental frequency and it is equal to 1 by t naught. 1 by t naught is the fundamental time period. Phi is the phase constant. So this is an example of sinusoidal wave. So the complete cycle is having a time period of t naught. This is fundamental time period. 1 by t naught will give 1 by f naught. F naught multiplied with 2 pi f will give the angular frequency. Now it is x of t equal to a sin omega naught t plus or minus 5. Plus 5 leading and plus or minus 5 lagging. So this is about the sinusoidal signal. And next signal is sinc function. Very important function is in the signal analysis is sinc function. The sinc function is denoted by SINC, sinc of t equal to sin pi t by pi t, and it is equal to 0 at t equal to plus or minus 1 plus or minus 2 plus or minus. So this is the basic sinc function. It becomes 0 because if t equal to 1, sin pi is 0. If t equal to 0, sin 2 pi is 0. If 3 equal to 3, sin 3 pi. Not about a t equal to 0, at t equal to 0, sine 0 by 0, 0 by 0 is undefined form. So applying El Hospital rule, it is sine pi by pi, it will be having some constant maximum value, that is 1. So this is the sinc function. It sinks continuously, sinc function. So it crossovers the 0 point at 1, 2, 3, minus 1, minus 2, minus 1, and so on. So this is about the sinc function and its definition. Similar function, another important function is sample function, SA of t. Both the definitions are same. Here sine pi t by n pi t by t, here sine t by t. So this is the only difference. Here pi is there, here pi will not be there, but the time scale is pi plus or minus pi, plus or minus 2, plus or minus 3. The same function is here, but the 0 crossovers are occur at pi, 2 pi, 3 pi, minus pi, minus 2, minus 3 pi. So this is about the sum. These two functions are usually used in the analysis of LTI systems and sampling of theorem and its proof, and the reconstruction of the sampled signal from its samples. So that is, in those things, these two are very useful, and while converting the continuous signals to discrete signal, these are very much useful. So next one is basic operations. So with this basic operations, there are two variables that you find in this, in any signal. One is amplitude, another one is time. So these two are the basic variables. You can change the amplitude or you can vary the time. So you can change amplitude. So if you are having low amplitudes, small amplitude signal, large amplitude signals. If you are having fast, high, minimum time period, we are having high frequency. Maximum time period, having low. Minimum time duration, that means high frequency. High frequency means, for example, if I am speaking, so if I start speaking like today's lecture is so and so, and it is having today's lecture is a signal systems. In the previous sessions I started to think, so immediately you will ask us, sir, please slow down your lecture because you are a little bit fast. This high frequency, very fastly I am speaking. If I speak slowly, yesterday's lecture was given on signals and systems. In that, basic signals and classification of signals are studied. If I start like that, you are immediately say, sir, it is too boring, sir, little bit fast. So that is slowing and fasting. It is time period is low frequency, time period is low, high frequency. So these two are the basic parameters that are available in a signal. So low frequency signals and high frequency signals, time and amplitude. So anyone can perform operations on amplitude or operations on time. So the operations which are performed on amplitudes are amplitude scaling, amplitude addition and subtraction, amplitude multiplication, and the operations on time independent variable is time shifting, time scaling, and time reversal. These are all the basic operations that can be performed on the signals. So this concludes for today's lecture, for this video, and the next video we will elaborate these operations. So amplitude operation means operations on dependent variable. Time operations means operations on independent. So we are having two types of operations on dependent variable, operations on independent variable. Thank you.